Nectaria Gizani from Greece Hellenic Open University, School of Science and Technology. So e-poster about Hellenic radio telescope THERMOpYlae, as I pronounce correctly. So floor is yours, and welcome in our conference. It's a pleasure to see participants from Greece, and we would interested in your talk. So
thank you very much for this interesting conference and for allowing me to send the delayed poster of ours. Since I have 10 minutes, and please correct me if I'm not, I decided to give you a brief overview of the radio telescope, which it was impossible to sum up everything on the 3-page poster. So I am speaking on behalf of the scientific team, Yorgos Veldes, who is the radio engineer of the project, and myself, who I am the radio astronomer of the project. We have managed to persuade the main telecommunication company of Greece to hand us a redundant telecommunication antenna of 32-meter diameter to convert it to a radio telescope. This antenna is placed in the historical site of THERMOpYlae, where Leonidas, with his Spartan warriors, gave a fight back in ancient Greek history, and that's why the radio telescope is called THERMOpYlae, and that's why we have the logo of Leonidas with holding the spear, imitating to be presenting it to be a radio telescope. So the telecommunication company has 3 redundant antennas. This one is the radio telescope. It's the newest antenna of all 3. This is another view of these antennas, and this is the one that we have. This is a historical monument, and this is a very an old dish, which was not exactly best suited for the conversion. So this antenna was used for monopoles auto tracking geostationary satellite signals at C-band. It was manufactured by the Japanese Nippon Electric Company in 1982. You see how the equipment is very well maintained. It's a typical telecommunication antenna with a C-band receiver for reception. The reception is at 4 gigahertz. Everything else is typical for the telecommunication dish. The azimuth and working range, you see, it's not exactly what astronomers what we want in order to be able to observe. So this is something that we are going to change apart from the receiver itself. Let me show you a bit inside. So this is underneath the antenna. There is a basement, which is all the RF equipment are situated. Here on the left, you see the ones that belong to us for the radio astronomy purposes. And this is the telecommunication instrumentation, which is obsolete at the moment. And it's obsolete since the dish is not working as for telecommunication anymore. This is the current receiving system of the antenna, the low noise amplifier, which has the right hand and the left hand and also a spare. You see also here the servo motor and the power control system, the altitude and elevation control system. You see how well everything is organized and maintained. And the control system of the antenna, which we are changing at the moment. And all these show you a very well-maintained equipment that the telecommunication company Cosmote gave to us after a memorandum of understanding. And they also keep the maintenance. That is, they clean, lubricate, and grease the mechanical parts. They provide electricity and the security of the instrument. So what we have done so far is that we have obtained collaborations and during a conference in Ghana about the conversion of redundant telecommunication antennas. We have made a feasibility report and we need we did the first iteration of the feasibility report, some preliminary RFI, which I have already shown the poster. Basically, what we have found is that using a spectrum analyzer of key site technologies in the band between 0 to 18 gigahertz, we found we found a signal at 1.9 gigahertz, which can be identified with a frequency belonging to mobile telecommunications. The waterfall diagram shows stability over time. The other thing is that these observations that we show here also connected with the directions around the antenna, the north, south, east, west, all showing these all showing this mobile frequency band. We also, these data were taken in the afternoon of May 2019. We repeated some measurements early November 2019 in the morning, and we also found an unknown origin of radio frequency interference, which could be which maybe didn't show up in May 2019 because of the difference in time of the measurement. And these unknown RFI seem to increase towards southwest direction. We also have had the Jumping Jive visiting us, confirming how well the equipment is maintained and how enthusiastic they are for the THERMOpYlae radio telescope to be included in the EVN and VLBI. We also obtained the know-how by making a trip to the sister antenna in New Zealand. And we also have established formal collaborations with our colleagues there. The current C-band system, feed system, seems to be working by using a very simple setup by connecting the spectrum analyzer with the C-band feed system and just observing the sun. We were able to see an increase in the signal, showing that we did see between quotes the sun. So the UV plots with and without the THERMOpYlae confirm that the Hellenic antenna is filling the inner region and provides the largest baselines of the EVN or VLBI. And this increases the higher angular resolution of the interferometer. So this is this is Sagittarius A UV plot without THERMOpYlae, and this is with THERMOpYlae. M87 without and with the THERMOpYlae, and M31 without and with the THERMOpYlae. So at the moment we are in the process of putting a dark fiber to the site. And the next step is to check the mechanical parts and make sure that there is accuracy, enough adequate accuracy for the dish surface by making a photogrammetry. We already have the collaborations for this. And of course, we need to perform more detailed RFI monitoring measurements over time, and to be able to see if we have any transient RFI and what the RFI environment of the antenna. The future plans is to install the dual polarization 6 gigahertz receiver, the astronomical receiver, to follow the Jumping Jive suggestions. We are at the process of, we have already the report of how to implement the interface of the control system. We need to be able to put the new one at the site, and we need to change these to change the mechanical part of the antenna to allow the for the azimuth movement of 270 degrees. Of course, we're going to go higher to SNX bands. And the plan is to, when in operation, to be able to have a standalone single dish functionality, the total intensity and polarization, both continuum and spectral line mode. We need, of course, the dish is going to be connected to the European and the global VLBI interferometer to increase the sensitivity of the instrument. But also we are going to have to make deep space telecommunications in collaboration with a telecommunication company that gave us the antenna. And of course, we're going to have SETI searches in collaboration with the Breakthrough Listen project, which is going to give us the back end. My colleague, Yorgos Veldes, is his expertise, he's an RF engineer, and his expertise in metamaterials, and he's making experiments on receivers with these new materials. So this is the antenna. So this is the global VLBI with the Greek antenna. And the last thing that I would like to let you know is that we have obtained a €2 million fund from national funds since spring 2020, exactly for a conversion. We already have, since July 2020, completed all the what is required for the telescope, all the instrumentation that we need to complete the conversion. Unfortunately, we're still waiting from the Hellenic Open University where I work. We're waiting for the Hellenic Open University to release the public invitation to the tender so that we are going to be able to purchase the equipment for the conversion. That's all for. Thank you. I hope I'm okay with time.
Thank you. We have reserved in time, but it was very interesting and I think very useful talk for our university and center. And I see Paco Colomer connected as well. And for EVN, because all of us, like urban telescopes, we go same way. We got old telescope and try to renovate it and equip with infrastructure, receivers, control systems, and VLBI equipment. And you are just starting with way, and I can say good luck with it. And I see Paco Colomer turning video and probably want to say something. And from my side, I see very interesting possible collaboration with Ukraine Zolochev telescope. They have very similar construction, also NEC telescope, and now they equip it, as you follow Oleg Ulyanov talk, with a new CQ band diapason receiver, double frequency receiver, and try to make own VLBI backend as well. So I think I hope to invite you in EVN family, and good luck again. And probably I can give word to Paco Colomer to say some good words as well.
Well, Nectaria, of course, we are very happy to see that there is progress in the instrument. It was actually my question was to whether there was a date that you could estimate when the first astronomical observations could happen with the antenna. Possibly it's not easy to answer, okay?
The thing, Paco, is that if, I mean, this €2 million that we have already obtained, this is the frustrating thing, that the university where I work is not releasing the funds. So this is something that is worrying. But we keep trying, and we hope to, because it's our scientific experiment. We have obtained this money. It's granted. So let's hope after that we will have the conversion ready.
So thanks for acknowledging the support of Jumping Jive. This project has finished, but I can assure you that Jive will continue supporting the work.
Thank you. Well, we need your equipment, so thank
absolutely.
you.
Okay.
And I notice you have 3 telescopes, but only one is available for register for me?
One is the new one and the good antenna. The other one is for historical purposes, and the third one is really, it really needs more to put it back. I mean, from the three, the one that we have is the best one.
Okay,
I mean,
thank you a lot.
Leonid from Jumping Jive could confirm that.
Thanks. It was a pleasure to see you in our conference.
Thank you very
And
much.